Okay, good morning, everyone, and perhaps good afternoon and good evening for those connecting outside Europe. While we let people come in, I'll give a short, very short introduction just to allow people to log on and realize that it's time for a webinar. I see quite a few people are coming in. For those coming in, do let us know where you're coming from. Feel free to use the chat. The chat is what we're going to use for questions. Make sure you can use that functionality. In the meantime, let me do a quick intro. So firstly, welcome to the Destination Earth Platform Webinar Earth Data Hub. So this is a webinar organized also in partnership with our colleagues from BeOpen, and Earth Data Hub is one of the core services available on the DestinE platform, providing a fast and operationally efficient gateway to access and analyze Earth data. Hello to everyone there in the chat. Good to see a few people typing in. Welcome. So basically, you'll hear a lot more from the service providers, but basically this service offers pre-processed, analysis-ready datasets optimized for cloud computing, helping users reduce the complexity of data discovery, access, and processing. Its catalog includes petabytes of Earth data organized into homogeneous collections and made available through standard interoperable technologies such as STAC, Xarray, and Zarr. So during today's webinar, we will hear from our colleagues in BeOpen, but also from our DestinE Platform operators. So we have representatives as well from Circo. Now, I think we have quite a few people in the room already, so I suppose we can start. But before that, I'd like to invite you all to first participate in a quick poll. But before that, a few reminders. So basically, we'll start with a quick welcome and introduction, followed by a poll, and then a brief introduction to the DestinE platform. We will also introduce BeOpen. Then we'll hear more about the Earth Data Hub, why, how, and what, followed by a live demo of the service, and then the ClimateDT OpenViewer downstream application example. Finally, we'll go into Q&A, but before that, we have another poll for you there. But that is the portion where we would invite any questions from you. So just as a quick reminder, this webinar is being recorded, so please feel free to anonymize your name if you don't want to appear. The recording and the slides will be made publicly available on the DestinE Platform Learning Hub. So also, as I mentioned, so please feel free to introduce yourselves, share the city which you're connecting from. At least that way you can test the chat functionality before the Q&A session. Also, just as a preference, so please do keep your questions until the end where we have a dedicated Q&A session. That's just, just in case some of your questions are actually covered in some later slides or some of the presenters will be presenting later. Also, we have a few questions for you to understand your needs and interest in the service. So please do participate to our polls. So I'll start with the first one. You should be seeing it now. So please do participate. So the first question is, how familiar are you with analysis-ready cloud optimized ARCO data? So yeah, looking forward to your participation there. The other questions that we have, so which service provider or platform do you usually use to retrieve climate data? And how do you usually access ClimateDT data? Let's see what they say. We have, okay, 2 participants participating now. Okay, let's keep it coming. All right. So far I see in terms of the familiarity with ARCO data, for now, 80% and counting are actually new to it. Following very far, we have those who know the basics but have not used it directly, and only very few in the single-digit percentage have actually used the data occasionally or regularly. That should be some interesting input for our presenters. Okay, and then how do you usually access ClimateDT data? Actually, 71% and counting do not currently work with ClimateDT data. Very far along, we have at 11% mentioning harmonized data access, Polytope. Two have actually mentioned the Earth Data Hub and others. So we'll see a bit more later. But okay, so I see that, yeah, mostly the responses have not really changed much. So yeah, that should be some interesting input for you. Okay, so I think with this, I suppose we can now start with our first introduction to the DestinE platform. So Barbara.
Okay, I need to share, probably, yeah.
Yes, let's stop now. Good. Okay, and it shows well. Yes.
Okay, good. Good morning, everyone. Thanks to Rob for the introduction, and many thanks to all of you for joining this DestinE Platform webinar. My name is Barbara Scarda, and I work for Circle. We are under a contract with ESA to implement and operate the DestinE platform together with an industrial consortium. So before handing over to the colleagues from partner Be Open, I'll take just a few minutes to introduce the DestinE platform and the context. So the Destination Earth initiative of the European Commission is set to develop a digital replica of the Earth, and it has three core components which are being developed by three entrusted entities. Now, the platform is one of these components, and it's implemented by the European Space Agency. The platform is, in fact, it's in fact the entry point to DestinE. It's designed to provide access to an ecosystem of services supporting evidence-based decision-making by tackling global challenges, that is to turn data into climate and environmental actions using advanced technologies. And it's built for a broad community that includes scientists, academia, but also policymakers and citizens. Now let's go quickly through the user journey on the platform, which depends on your user type. So the first step is for users to join the platform, and by joining you can find general information. You can register following a standard process, which the standard registration will allow you to access a number of selected services, and you can find help under resources and contact us directly from there. A bit more in detail, you click on services and you can filter the drop-down menu by DestinE data, thematic area, and target audience, or you can directly browse through the catalog of all the available services, and for example, filter them by name or tags. There are various options for filtering inside the catalog. And on each service page, you will find the relevant documentation. We also have a sub-website that is called the Learning Hub, and it's available from resources. This is where you can find a series of educational material that includes, for example, under training, the services video tutorials, and also the recording of this webinar will be published in the relevant webinars section. And on the Learning Hub, you will also find the demonstrators, some interactive tools that also include climate games and other resources. A quick look at the platform roadmap, which is also accessible from resources on the navigation menu of the DestinE Platform web portal. This is where you can find a list of recently released features, upcoming functionalities, and most importantly, ideas for improvements suggested by the user community. This is part of our effort to stay transparent, make sure the platform evolves based on real user input. Now, once you've joined as an expert user, you're ready to engage with the platform advanced services. In particular, in the About section, you can visit the Climate Digital Twin page, where you can find a thorough guide through all the relevant information, including how to access and use the digital twin simulations. So I invite you to have a look at the page. You can also browse the list of services on the platform that provide access to ClimateDT data, like, for example, Earth Data Hub. And in order to use these services that enable you to download DestinE Digital Twin data, you need to apply for upgraded access. So after signing in, just go to your profile in Access Policy Upgrade and complete the form. Here you have the list of all the eligible categories. Going on, another category of users on the DestinE platform are the contributors, therefore external service providers who wish to onboard their services on the platform for extended visibility, to join the community, and they also have the possibility to benefit from our cloud infrastructure. There is a dedicated section on the web portal, onboarding, where to find all relevant information and the process in place. And concluding, we invite you to be part of the DestinE Platform community based on your experience, and follow us on the web portal and on our LinkedIn page for the latest news and updates. And for the future, we will keep adding new services and new data sets with more and more innovative features and capabilities, so that we keep developing the ecosystem. So this wraps it up. If you have any questions, feel free to ask now in the chat, or get in touch later by the Contact Us form from the web portal. Now I'll hand it over to Matteo Almansi from BeOpen. Thank you.
Thank you, Barbara. I'm going to share my screen. Share. Okay, hopefully you see now the presentation.
Yes. Yep.
Yes, so good morning, everyone. My name is Matteo Almansi, and I'm software engineer at BeOpen. And today I'm going to talk to you about the Earth Data Hub. This is the agenda for today. Rob already went through it, so let's just dive into the Earth Data Hub. But before we do that, I want to give you a bit of an introduction about BeOpen, so you get to know a bit the people behind the Earth Data Hub. So we are an Italian company. We are based in Rome. And right now I'm speaking from our headquarters here in Rome. And we have about 20 years experience in various fields, and the past 10, 15 years, we've been working heavily on this kind of services. We are about 30 software engineers. Actually, we like calling ourselves scientific software engineers. So most of us have different backgrounds in science and different application. Myself, for example, used to be a physical oceanographer. So we follow the whole development cycle of the software that we build, but we are also quite experienced with the science behind the software that we build. And we work with many of the European agencies, ECMWF, ESA, EUMETSAT, but also private companies as well. And just to give you an overview of the main activities that we are working on at the moment, we are involved with many European data services. Earth Data Hub is one of them, but we are also involved with the Copernicus Climate Data Store and the EUMETSAT Data Tailor. So many of the services that you probably use in your everyday work to download data. And we also work on applications, one for EEA, for example, or Windstorm Track for C3S, and in data processing as well. An example is we are involved with the processor for Sentinel 1 and 3. And we have a whole division focused on R&D as well, focused on algorithm for remote sensing. And finally, we are very proud of being quite active in the open source community. You might have seen myself or many of my colleagues contributing to libraries such as Xarray, FSpec, Zarr, CFX Array, and we also have our own libraries that we develop and maintain Xarray Sentinel, CFGRIP, and many more. Okay, let's dive into the Earth Data Hub. So in this slide, you see basically the target data set that we are serving through the Earth Data Hub. So they are geospatial data cube. And with geospatial data cube, I mean discretized representation of the Earth, usually done by simulation, but not only. And these data cubes have at least 3 dimensions. So you often have latitude, longitude, and the temporal evolution of the properties of the Earth. But sometimes we also serve 4D datasets. So example, you could have pressure levels or depth for the ocean and so on. So data cubes is the main target of this service, and I want to stretch that we are not really data providers, but what we do is we basically bring data from other sources into the Earth Data Hub, and we reformat it to make it available through our service. So I have seen from the feedback before that many of you are not familiar with ARCO. So this is the main technology behind our service. It's an acronym that has been quite used in the past 5 to 10 years, and it means Analysis Ready Cloud Optimized Data. And our recipe for converting the data into ARCO and make it available with this technology is basically 3 main ingredients. The first one is that we make extensive use of an object store, and in particular we use OVH Cloud, which is partner of the DestinE Platform. So all the data that we are serving are actually stored in object storage provided by OVH Cloud. Then we decided to reformat all the data that we are taking from different sources, and we are bringing it into the Earth Data Hub in Zarr. So Zarr is a quite new format, let's say. It's about 10 years old, but has been a great new feature in this ARCO world. There are many formats that they can be picked for distributing data, and Zarr is really a great one. And I have a full slide later to show you and tell you a bit more why we decided to use Zarr. And finally, we try to align as much as possible with the new technologies and standards that are emerging, and STAC is one of them. So we have a catalog that is fully compliant with STAC, this Spatial Temporal Asset Catalog. Okay, so why Zarr? Why we decide to align with this format? Well, the main great feature of Zarr is that it is very, very easy to define chunks for the dataset that we are going to serve. And these chunks live completely separate from each other. So instead of having a monolithic file with all the data in the same file, it is very, very easy to distribute the data into the object storage. So this data format is great for many reasons. First of all, because these chunks are all separate, it is great for parallel access. So users can easily have their application accessing these chunks concurrently. Then it's a perfect fit for cloud storage systems. That's because we can easily distribute all the data across the object storage. And finally, another great example of the advantage of using Zarr is that it's very, very easy to do selective access. A simple example, say you are an Italian researcher studying dynamics over the Alps. Yes, with Zarr, it's very, very easy for you to, if the chunks are properly, if the data set is properly chunked, for you, it's very, very easy to access just the data that you're going to need. That means that you're going to download or access way less data than you would have with other file formats. This is the core feature of Zarr and why we decided to use Zarr. There are other important features for Zarr. For example, it has a big compression flexibility. For example, we decided to explore bit round compression, which allows us to reduce a lot the size of the data that we are storing while keeping the data scientifically sound. It has a very diverse ecosystem. At the moment, there are at least 10 official implementations of Zarr in many different languages. And finally, it is a great data format for accessing metadata. The metadata lives in a separate JSON file, which is very easy to access, explore, and downstream application can easily understand how the data is organized without having to read all the data. Now, but let's talk a bit more about specifically the HERT Data Hub. So we worked hard to keep our service as simple as possible. And in practice, you only need two ingredients to access HERT Data Hub data. First one is an API key. That's a simple token that allows you to have credentials associated with your user. And the second ingredient is a URL. So in a bit, I'm going to show you our portal, and you see that we have a catalog with many datasets, and each dataset is associated with a simple URL. So once you learn how to browse through our catalog, you'll see that it's very easy to retrieve a URL for the dataset that you need. So once you have your URL and you have your API key, that's pretty much it. You can plug this information into softwares to retrieve data, and you can start crunching the data. So we don't have a bespoke client. We didn't build a client or an API just for the HERT Data Hub. So all you need to do is plug this information into your favorite technology to start accessing the data. There are different technologies out there. We have a go-to library, which is Xarray, and that is mostly because we work a lot with it. And as I said before, we have been contributing to many features of Xarray in the past. So you will see a lot of examples using Xarray on our web portal, but in practice, there is no constraint for you. You can use other technologies in different languages. There are, I don't know, Zarrita, probably GDAL, and many more. So, or you can build your own one, as we are following just simple standards. So if you want to build your own software from scratch, it's going to be quite easy to do that. So this is how a snippet looks like in practice. So once you have the dataset and you have your API key, all you have to do is importing the library, Xarray, and you plug that information into the open dataset function. And that's it. You can start analyzing the data, and Nicola in a bit is going to show you a bit more about how to do that. And yes, there is task in the background in parentheses here. That's because in the backend, Xarray heavily uses task. So by using Xarray, you can simply activate multiprocessing and easily start scaling your analysis. Okay. Now, this might feel a bit like magic. So the service looks like it doesn't really have a server. So in traditional services, usually you have to learn an API, you send a request in, and most of the times there is some kind of brokering system that puts you in a queue and tells you when your request has been processed and served. Here is a bit different. And there's no magic, but the most important part of the work goes into how we chunk the data sets. So we are basically shifting the effort from like the brokering side of things to the chunking scheme. So it is very important that the data set that we reformat into the Zarr data format are aligned with the common access patterns of our users. And in general, there are two main chunking schemes that we are using in the HERT Data Hub. One is maps optimize. Sometimes it's called also pancake chunking or lasagna chunking. And you can think at it like think about 2D images stacked on top of each other. And this is a great chunky scheme, for example, if you need to display maps or evolution over time of large areas, these kind of things. And the opposite chunking scheme is the time series optimized chunking schemes, sometimes called referred as churros chunking or lasagna or spaghetti chunking. And this is a great chunking when you have to analyze long time series, but in specific locations. A simple example could be climate stripes. So example, if you want to see how it's changing the climate in Rome in over 100 or more years, that's the perfect chunking scheme that will serve your use case. So for the most important dataset that we are serving, like ClimateDT, we have both chunking schemes available in the system. So in the dataset, in the catalog, you will see that you have the option to get a URL for either the map optimized chunky scheme or the time series chunky scheme. So you can choose what's the best scheme for your application. So this is it from for slides. I just want to go and give you a very brief overview of our portal, so you learn how to navigate in the portal, and then I'm going to leave the floor to Nicola for the live demo. So now you should be able to see the portal. This is our landing page. It is basically all the information I just gave you in the slide in a compressed form. And same as the service, our portal, we try to keep things as minimal as possible, so you don't have to learn many new things to navigate through our service. We only have 4 pages here on top, and these 4 pages are quite important and different scope. So the first one is the getting started one. So here, if you are first user of our service, I really recommend you to go through this. It looks like a lot of text, but it's really just a couple of minutes reading. And here you will find all the information on how to access our datasets. So as you can see here, this is the snippet I showed you before, and there is also some word about how to get your API key, so you can plug in the credentials in your downstream software. Then we have a catalog. We decided to divide all the datasets, to group all the datasets in STAC collections. So at the moment we have 6 of them. You can see ER5, ClimateDT, CMIP6, and a few more. So each collection has different items in it. So example, let's click on the ClimateDT one, and you see that you will find a lot of datasets. All the datasets that we are now serving and are associated with the ClimateDT collection. And as I said before, you will see that sometimes you have same dataset with a time series chunking scheme or a maps chunking scheme. And if you click into the dataset, you will see the snippet to access this specific dataset and a few extra information, such as the variables that are associated with the dataset itself. And just to close it, we have a few tutorials, and these are basically Jupyter notebooks that give you an idea on how you could use Xarray mainly to access and make some nice plot or analysis. And finally, the contact page. You can either get in contact with directly with us at this email address here. This will put you in contact with the developers of the Earth Data Hub, or if you have more questions related to the platform, there is a DestinE Platform user support team as well. And with that, I'm gonna leave the floor to Nicola for the live demo.
Yes, thank you, Mattia. I will just share my screen. Okay, hopefully you can see it. So, good morning, everyone. My name is Nicola Masotti, also from BeOpen. I am one of the developers of Earth Data Hub. In this part of the webinar, we will run together a Jupyter notebook showing how to access one of the climate adaptation digital twin datasets on Earth Data Hub, We already said this, the access to these datasets is granted via standard destination Earth API keys, but is restricted to users with upgraded access. So if you don't have upgraded access, you can apply the things we will see today to other datasets that you can find on the Earth Data Hub that don't require this particular upgraded access. The goal of the tutorial is to walk you through a typical Earth Data Hub workflow and provide you with useful insights on how to get the most out of the service. Before we start, since we are using a climate adaptation digital twin dataset, I must say that ClimateDT data is available from Earth Data Hub only for a selected set of variables that depends on the resolution of the dataset. We have more data for the standard resolution variables and less data for the higher resolution datasets. The data has been regraded to a regular latitude and longitude grid, compressed and made available in Zarr format to facilitate cloud-native regional and time series analysis. If you want to access the full ClimateDT portfolio in its original form, you should refer to the Polytop service. So, if we want to preview a dataset using Earth Data Hub service, what you typically should do is to go to the service catalog tab, select the collection you want to access, select the dataset you want to access. Today we will use the IFS NEMO SSP 3.70 dataset for the climate adaptation digital twin. And as Mattia showed previously, you get a couple of suggestions on how you can access the dataset. If you make sure you are logged in, which I'm not, you can click on this eye and see that the website already suggests you a simple code snippet that you can use to access the dataset. You can copy the code snippet, go back to your environment. In this case, it's a Jupyter notebook. Paste it. I already have it here. And this will already provide you access to the dataset. You can see the URL integrates the API key that you need to access this dataset or any other dataset on Earth Data Hub. This will take a few seconds, and when it's done, you get the usual Xarray preview of the dataset. You can inspect all the variables inside the dataset. You get information about dimension, coordinates, all the typical Xarray stuff. You can inspect one variable more in detail. We are looking at the 2-meter temperature. What is important to notice when using Earth Data Hub is the chunking of the dataset. Mattia talked about this earlier. In the specific case of this dataset, we will have 1,440 pixels or indexes chunking in time by 64 pixels in latitude by 64 pixels in longitude. This is the minimum amount of data that corresponds to a single chunk that you can download from the service. Another thing that is quite interesting to look at is the size of a single variable, which even if this is the standard resolution ClimateDT dataset, it's around 600 gigabytes of data. So you can guess we didn't download all this data just by accessing the dataset, and you shouldn't be probably even trying to download all the data at once. Earth Data Hub is not a go and grab everything you can platform. The goal is to expose analysis-ready data so that users can do their analysis and leave the data where it is. So you don't have to pay for storage, and if you use other DestinE platform services such as Insula Code, you don't even have to pay for computer resources, so you can do all your analysis and processing remotely. The typical Earth Data Hub workflow involves, for this reason, one or more subsetting steps that today we will do with Xarray cell and iCell functions, typically followed by one or more analysis, reduction, or visualization steps such as min, max, plot, or whatever your analysis is. I just wanted to show you that you can also declare the API key separately and integrate it in any dataset URL if you plan to use more datasets at once. And while doing this, I also wanted to show you that a couple of parameters that we typically integrate in our code snippets are actually not needed if you use a recent version of Xarray and Zarr. We won't be doing anything scientifically relevant today, but we will do a couple of data access just for example. So suppose we want to access and compute the average 2-meter temperature in continental Europe for today. So this is these are more or less the coordinates of continental Europe. And what we can do in Earth Data Hub is just to get our dataset accessor, select the 2-meter temperature, select the continental Europe region, select all the timestamps belonging to today's date, which is going to be 24 timestamps for this dataset that it's an hourly dataset. And we can also look at it in this form. So it will be a continental Europe selection of 24 timestamps. And then we can do the average of the day and plot the result. While the plot comes out, I would like to point out that there are two distinct parts of in this one-liner that we used to get our result. If you're familiar with Xarray and Dask, you probably know it, but up to the min function included, Xarray was operating lazily, driven by Dask. So it means that up to this point of the one-liner, no data was downloaded, nor loaded into memory. You were just getting a preview of what is your the result of all the selections and operations up to the min function. When you call the plot function, the data is actually downloaded, loaded into memory, the computation starts, and you finally get your plot result. If we look at this more into details, so this part of the operation is lazy. Once you call the plot function, it will take a little bit more. You cannot notice this right now because I'm operating from a fast internet connection and the quantity of data we are downloading from the hub is very small, so everything is pretty fast. But if you are going to download more data, you will notice a difference between when you do lazy operations and when you actually trigger the download of the data. If you try to access the values, same as before, you are downloading the data and loading it into memory. So aside from data accessors and functions such as values or plot, there are more ways in which you can trigger the download of the data and load it into memory. And if you're familiar with Dask, you know that these are the compute and load function that both serve this goal. If you use the compute function to load your data into memory, remember to assign the return of the function to a variable, otherwise it will not be kept into memory. So I want to look at this a little bit more in detail. So if we define our selection and also the min operation into a variable called T2M Europe, we know that up to this point, everything is lazy. If we compute our selection and we store it in a variable called T2M Europe computed, we know that the download is triggered and the data is loaded into memory. So if we take a look at what is going on behind the scene, we can see that if we print the type of T2M Europe data, which was the lazy part of our data access, it will tell us that this is still a Dask array. If we print a type of T2M Europe computed .data, this is now a NumPy and dimensional array, meaning that Dask is out of the way and the data is loaded into memory. So every operation that you do when the data is already loaded into memory will be very fast. For the sake of time in this demo, we are using a standard resolution dataset, but everything I showed seamlessly applies to any dataset on Earth Data Hub, including ClimateDT high resolution dataset. I have already copied here the snippet for the corresponding high-resolution dataset, and we can see we can use the same syntax to access the high-resolution corresponding dataset. Just to point out something, as Mattia previously said, we have when the dataset is very high resolution, we can have different chunking schemes. So in this case, I want to plot a map, so I'm using the maps chunking scheme, which will make my processing faster. So one important concept in Earth Data Hub is that you have a limited number of monthly downloads, which is 500,000 requests that correspond roughly to the possibility of downloading 500,000 chunks of data. I would say that if you're doing small regional and single-shot analysis, such as the ones we are doing today, you don't need to worry about your quota and you don't need to check your quota all the time. It will likely be enough. If you are doing instead heavily parallelized repetitive data access, there are ways in which you can optimize your usage of the service that we don't have time to go into details. But something you can do for starters is that you can plan and estimate your consumption using this costing.py module that we distribute alongside with many of our tutorials. And if you import the costing.py module and define a specific selection of the dataset you are trying to access, you can then call this estimate download size function on your selection, and you will get an indication that you will need to download a total of 6 chunks for around, in this case, 27 megabytes of data, which is the compressed size of the data that will become a little bit larger when you load it into memory. Something that you should be aware of is that when you use this convenience module and function, you should pass to it the selection you want to do from the Earth Data Hub before you apply any operations such as mean, reductions, or any other arithmetic operations. Otherwise, the function won't be able to estimate the correct size. So where the system really shines is when you try to access point or regional long-time series, which is something that conventional data provider systems typically fail at. And so I would like, as a final example, to show you access to a point time series of the 2-meter temperature on Bruxelles for the next 10 years. So we go back to our dataset accessor. This is just a preview again. When we do select the 2-meter temperature, we select the nearest neighbor point to Brussels, and we subset the next 10 years. We get the preview of our point time series. And again, we can compute the cost of doing this operation. In this case, we will need 68 chunks for a total of around 300 megabytes of compressed data. We will now use the load function instead of the compute function to load the data directly in the T2M Bruxelles variable. This should take a while because we are downloading this amount of data. And finally, we can check that the type of data will be a NumPy and dimensional array. And to do an operation and plot the result when the data is already loaded into memory will be basically instantaneous because we did the difficult part in the loading step. So this concludes the hands-on part of the webinar, unless I have more time. I don't think so. So I'll leave the floor. Okay, so I'll leave the floor to Ignacio. Stop sharing.
Okay. Thank you, Nicola. I'm going to share the screen. Wait. Okay. Do you see it?
It has to go to presentation mode.
Yeah. Do you see it?
Yes. Yes.
Nice. So yeah, thank you, Nicola, Mattia. Yeah, so here I'm Ignacio Valles. I'm working in Predictia, and we are developing an OpenViewer that will be implemented soon in the DestinE platform. And I think it's a pretty nice example of a system, of a platform that it's built on the top of the Earth Data Hub. So the idea of this OpenView is to be a window where the users can access to this set of kilometer scales models of our resolution. So as you might guess, it's just 100 of gigabytes, a lot of terabytes of data that without enough computational resources or some expertise in code, it's not users normally don't have the ability to explore them. So the OpenView will be a window where the users will not only to explore how this data looks like, but also to understand, but even more to interrogate and interact. So and here in that side of interrogate and interact with the data is where the Air Data Hub makes it possible. So I'm going to show how the data viewer looks like first. Let me know you see the web.
Yes.
Okay, perfect. So here the data viewer, it's basically composed of three main sections. Four main sections. The first section is a climatology section where you see here a global map of climate indexes. In that case is temperature, maximum temperature, daily temperature. And you can explore easily, you see in detail how this kilometer scale resolution can resolve nicely, for example, the Alp mountains, as Nicola and Mattia have noted before. So the other sections, another section is the climate stories, where here we show some climate stories that only this type of kilometer scale models can resolve. It can be extreme precipitation in the Mediterranean and northern headland. But where I want to go is the custom index section. This section, the custom index section, is where the user can interrogate the data viewer some indices that in the climatologies we don't have it. So, for example, some users might want to know how is the extreme precipitation, how is the precipitation accumulated in 6 hours, in 5 hours, in 2 hours, or how in the number of days that, for example, the minimum temperature do not go below 20 degrees, which is typically known as tropical nights. So these type of indices are able to, we make the user able to compute them without using any computational resources and any code. So we go here in the custom index, we select an area, a small area, or for example, now if we go zoom in and we go, for example, in Catalonia, we select a small area in Catalonia. We go to the next step. We select one of the variables that are available in the OpenViewer. In that case, we might select temperature. And we have a menu where we have different options, different operations that define the index. No, for example, we want to know the minimum daily temperature. So we resample. We choose resample. We choose day. Then the next operation will be a minimum. The next operation will be filter. So filter when this minimum daily temperature is more than 20 degrees. And then the last operation will be count. Okay. We go to the next step and we decide the monthly aggregation and the seasonal aggregation. In that case, we are counting. So we are choosing sum for both. And we have a summary of the climate indices that we decided to explore. And if everything is okay, we create the index. Now it's still under development, but that would be a nice way. Then when we create the index, we have a map with that index and also the monthly time series of that index for the three models from the 90 to the 2050, from historical to future simulation. and also the relative change between both periods. So how this can be made, and I'm going back to the presentation, how this is made is this is the architecture behind the custom indexes, where the user interface is this menu where the sites each operation. Behind the user interface there is what we call a JSON scheme, which basically validates what the user decides to do and says that it's okay or not. And it's a bridge that connects with this Xarray Zarr ecosystem in which Earth Data Hub is built. So thanks to the chunking strategy in which the Earth Data Hub is built on, that Matthias explained it very well, we are able now to use the functions inside the Xarray, select the area that the user defined, and compute the climate indices. Once the data is computed and is computed inside the Earth Data Hub, it's uploaded to the service where the data viewer reads this data and displays it in the data viewer. So it's pretty much everything thanks to how the Earth Data Hub is built. So for any questions on that, I will be very grateful to answer. Thank you.
Okay, thank you very much, Ignacy. All right, I invite my fellow panelists to come back to the stage. Before then, we'd like to share with you another poll. So you should be able to see it now. We would like to gather some feedback. So have you ever used the Earth Data Hub, or do you plan to use it in the future? Meanwhile, I think it might be worth already going into the questions, because we have quite a few in the chat. Let's start with perhaps the first one on the list sent earlier. There's a question, do you use Xcube? From the panelist. Yes.
Yes, I can answer to this question. So I personally, I'm not very familiar with Xcube. I know, like, I heard about it and know about it, but that's the beauty of the Earth Data Hub. So you can use any technology you like for accessing the data. So providing that Xcube has some functionality to access our data, which is very likely. I don't know the library, but I'm pretty sure that in line with ARCO datasets, you can use Xcube for your downstream application with no problem.
Okay. Next, we have another question. What is the backend technology behind the platform?
Well, so this is a hard. There are many technologies, let's say it this way. So, for example, for the whole part where we build and construct the datasets, we are also heavy users of Xarray, Zarr, and these kind of technologies. And we are mostly Python users. But then we have also the whole DevOps team that has their technologies, Kubernetes classes, and these kind of technologies. We have a gateway that used to be an Nginx gateway, but the technology is changing quite a bit to align with the platform. So many technologies start to provide just a single answer for this one.
Very well. Next, we have from Peter. Can we generate and get an Earth Data Hub API key programmatically if we already have a DestinE user, or only through the DestinE Platform UI?
So I'm not completely sure, but I don't think you can do that. And especially for the dataset where you need upgraded access, there's no really point to do that, because you will need to submit a request for your upgraded access to be accepted by the European Commission. So, I mean, the service is meant to be used for a single user as a single API key. So I don't think you can do that, but also there is not really much point of doing it.
Maybe I can add something to this. There is another way in which you can tell your tools what is your API key, which is to store the API key in an .rc file. This is described in the Getting Started on the website. And if you do that, basically you have to get the API key once, put it in a file, and you're done. You don't have to worry about the API key anymore. So there's really not much use for a programmatically way of getting the API key if you just have to do the operation once.
Another question, this came up during the live demo. So is this notebook available online? I think it was referring
Yes,
to.
I can take this one as well. So this specific notebook, it's not yet available online, but it's quite similar to many other notebooks that we used in other presentations. So you can either go to the website where in the tutorial section, you will find very similar notebooks, or you can go to the Insula Code service with which we have an integration and find a Jupyter notebook from a Destination Earth user exchange a few weeks ago, was run a few weeks ago. That is basically the same notebook. So just go on Insula Code, you will find basically the same notebook we showed today.
For that. Just a little organizational note, please remember to type your questions in the chat. Unfortunately, we can't accommodate hand raises and to give you the floor. So yeah, just feel free to use the chat for your questions. Next question, is there an overview of the available variables that can be checked before starting to use it?
Yeah, Mattia,
Yes.
both of us.
Well, I'll start. There is an overview of the variables for each dataset, and that's in the portal. I'll show you during my overview of the web portal. So if you click on the dataset, you're also going to see all the variables that are available. But there is also another beautiful feature of this technology is that when you open a dataset, it is very, very easy to just read the metadata associated with the dataset. And in this metadata, there is also the full list and description of the variables that we are serving, and everything is powered by a STAC catalog. So if you know that technology, you can connect your downstream software to the STAC catalog and easily programmatically browse to all this information. And Nicola, I don't know if you want to add something.
No, that was all.
Okay, in the last 3 minutes of our webinar, so we only have a few questions left. What is the difference between accessing data in Earth Data Hub and CDSE? Is one more expensive than the other?
We are the climate team mainly. So I think CDSE is mostly for Earth observation. So they are quite separate in this sense. So today we focus on climate. I personally not very experienced with the CDSE, so I can't really go into the details, but I think they are quite different services that serve different purposes. So yeah.
For the moment, they are two very different catalogs, although we are working on the Earth observation side as well to try to integrate in Earth Data Hub Sentinel-1 and 2 data, but it's still a work in progress. So for the moment, I would say there are two separate services that serve two different types of datasets.
Okay, another question, when will cache be shut down?
Okay, maybe I can take this. So this it's still operating underneath. We already discontinued it, but you can still do what you used to do with the cache B in background. But I think more importantly, to switch to the new API, DestinE API key, is just a matter of substituting the old URL with the old cache B token with the new URL and the new API key. So it's really, really, really easy. I suggest everyone that is using cache B move on to the new system.
Thank you. Another question, are the HDA and Earth Data Hub services related? For which use cases would you recommend one or the other?
Okay, I can take this. So the harmonized data access, not an expert of it, but I think it's very similar to the PolyTop service. So it distributes data in its original form, which is the helpix grid. So we differentiate in terms of grid and a subset of distributed data. And I would say if you want the original helpix grid data, you can use either the PolyTop service or the HDA service. If you want the regraded latitude-longitude version of the data in the Zarr fashion, you should use the Earth Hub. We also are very strong into serving regional and time series analysis, and depending on your usage, you might want to go to one service or the other.
Very well. Last question, can it run on Google Colab or only on Jupyter Notebook?
I don't see any reason why it cannot be run on Google Colab if you have the right environment with Zarr, Xarray, or whatever Zarr compatible tool installed in it.
Okay, very well. I think that's all the time we have for today's webinar. Thank you very much, everyone, for your very active participation, especially also to the polls. Just a quick note before we leave, we will organize likely another webinar next week. So stay tuned for the participants. Just watch out for our next updates because we'll be announcing that shortly. So with that, I think we can close. Thank you very much to you all for today. All right, we'll see you next week. Bye-bye.
Thank you.
Thank you.